Since the beginning of the first semester, we have frequently used concepts such as regression analysis, linear regression formula, quadratic regression function, exponential regression function, etc. While using the regression formulas, we mentioned that these formulas are functions that fit the data obtained based on some observations. Each time, I thought you would learn how to analyze it in the future. Now it is the time to learn this analysis. In this section, I will explain how to perform regression analysis. This analysis is also known as the least square method. Although it is possible to perform different regression analysis with some different methods, in this section we will discuss how to obtain the linear regression formula with least square methods for a given data. So briefly, the regression analysis is the process of fitting an elementary function to a set of data points by the method of least square. Using regression techniques, we introduce how we can use the regression techniques were introduced in the first chapter of your textbook we discussed in the first term. Now, using the optimization techniques, maximum minimum to find the maximum minimum of the functions, we can develop and explain the mathematical foundation of method of least square. We begin with the linear regression, the process of finding the equation of the line that is the best approximation to set of data points. So, on the example, let's look. For example, the following data is given. Okay, suppose that a manufacturer wants to approximate the cost function for a product. Okay, so number of the units, which is not by x, it is 100, and cost with not by the y, the unit is $1,000. So, according to the observations, when x equals 200 or x equals 2, the cost is $4,000 for. Okay, for when x equals 5, the cost is 6. When x equals 6, the cost is 7. When x equals 9, the cost is 8. So we can plot these points on the Cartesian coordinate system easily. For x equals, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9. For x equals 2, y is 4. Okay, so let's say 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4. This is our first point. When x equals 5, 3, 4, 5, this point, price is 6. That point. When x equals 6, $7. This is another point. When x equals 9, $8. These are the R points, okay? So, our aim is to find a line, okay, which represent this data best. So, what is the equation of the line? Y equals ax plus b. So let's show that that line, actually we don't know what is the a and b. Our aim is to find the a and b. So let's say this line is the best line. I don't know actually. Okay, I showed that this is the best line. For example, this is y equals ax plus b. So the manufacturer would like to approximate the cost function by a linear function y equals ax plus b. Determine value, so our aim is to determine the values a and b so that the line is in some sense the best approximation to the cost function. So what do we mean by the best? Since the line y equals ax plus b will not go throughout all 4 points, it is not possible, there is no such line, it is reasonable to examine the differences between the y coordinates of the point listed in the table I will write, and the y coordinates these values, and y coordinates of the corresponding point on the line. Okay, so I mean, let's use this one. Let's make another table. X, y, the value ax plus b, and we will define the new concept residue. This is the differences between the exact value and the approximate value. So for the x equals to, y is for its exact value. 2, 4, 5, 6, 6, 7, 9, 8. And for the residue, for the line, for x equals 2, this is the value of the line. So this value is 2a plus b. Okay. For the point 5, this point is 5a plus b. So this is 2a plus b, this is 5a plus b, and at the point 6, this is 6a plus b, and for the x equals 9, this point is 9a plus b. Okay, so 6a plus b, 9a plus b. Y value are the exact value. X plus b value are the approximate value. Our aim is to find the best line. So, according to this aim, we will minimize the differences, actually not differences, square of differences, but let's first of all calculate the residual. So our aim is to minimize the differences between these two values. Okay, so the residue between the residue is called the each differences. Okay, I mean each of these differences is called the residue at the point. Okay, at the related point to 5, 6, and 9. So let's write the residues. 4 minus 2a minus b, 6 minus 5a minus b, 7 minus 6a minus b, and 8 minus 9a minus b. Our criteria for the best approximation is the following. Determine the values of a and b that minimize the sum of the squares of the residuals. Okay, so we define the following function. F of ab, square of the first residue, 4 minus 2a minus b square. Why we take this square? For example, here this is positive, this is not negative. 4 is less than 2a plus b, but here it is positive. Okay, 8 minus 9a plus b is positive. So this is negative, this is positive. So if we take the square of all of them, we minimize that function, we will find the best value. Okay, if you minimize this summation, since some of them negative, some of them positive, it causes a wrong calculation. Okay, and plus 6 minus 5a minus b square plus 7 minus 6a minus b square plus 8 minus 9a minus b square. Okay, so this is our least square function. Actually, not least square function. Generally, we don't say least square function. This is our objective function. Our aim is to minimize this function. Okay, so our aim is to minimize this function. Okay, so to minimize this function, what we can do, we should calculate all partial derivative, and we should find the critical points. So according to this aim, the partial derivative of the f with respect to a equals, let's turn back here. Here we have this one, 2 times 4 minus 2a minus b times, with respect to a we differentiate, minus 2. Okay, so 2 times 4 minus 2a minus b times minus 2 plus here 2 times 6 minus 5a minus b times derivative of the minus 5a with respect to a is minus 5. Okay, so 2 times 6 minus 5a minus b yes, times minus 5, and it continues by this way. 2 times 7 6a minus b times 6 and 2 times 8 minus 6a minus b times minus 9. So let's write 2 times 6, we have already write the 6th term. 2 times 7 minus 6a minus b times minus 6, and 2 times 8 minus 9a minus b times minus 9. If you make some arrangement on that one, you will find minus 304 plus 292a plus 44b. Okay, partial derivative of the f with respect to a. Similarly, you can calculate the partial derivative of the f with respect to b. 2 times 4 minus 2a minus b times derivative of the this function with respect to b, which is minus 1. Always this is minus 1. So 6 minus 5a minus b times minus 1. 2 times 7 minus 6a minus b times minus 1. This is not 6, this is b, sorry. 2 times 8 minus 9a minus b times minus 1. And after calculating that value, you can find minus 50 plus 44a plus 8b. By making the all partial derivative are 0, f of a equals 0 and f of b equals 0. And by solving together these two equations, minus 304 plus 292a plus 44b equals 0. And minus 50 plus 44a plus 8b equals 0. You can solve this system easily. Okay, if it is possible, you can make some cancellation. There is no problem. For example, you can cancel by dividing 2. This is 152. This is yes, this is 146. This is 22, and also here this is 25 minus 25. This is 22. This is 4. Okay, so by solving these two equations, you can find the A value as a 0.58 and the B value as a 3.06. So with these values, the function f of ab is the smallest, most probably. But by using second derivative test, we should verify, okay? So this is our critical point. Is the critical point. Okay. So let's calculate. So let's show that this is minimum value. Okay, actually the function capital F attains the minimum value at the point 0.58, comma 3.0.6. Okay, so using the second derivative test. So we should calculate f of sub AA. From here you can calculate 292. This is 0, this is 0. 292. F sub AB, AB. Also this equals f sub BA, but this is okay. So the first derivative of the, then with derivative of f with respect to B, so 44. This is 44. Also from here you can find 44, okay? And f sub BB at the point AB is 8. Okay? Actually, we say this is A, this is B, this is C. So AC minus B square, we should calculate this value. 292 times 8 minus 44 square. Please look to second derivative, which is 400, bigger than 0. And we should look to A. Either this is local minimum or local maximum. This is not a saddle point, okay? So if A is bigger than 0, A is 292, so it is a local minimum. So therefore, according to the theorem in your textbook, okay, f of AB has a local minimum at the critical point. At the critical point 0.58, 3.06. Actually, this function may be the second partial derivative may be depends on the A and B. So by calculating the function value f a b at this function, you can decide. But since our function, capital function f, is a linear function, always these will be constant, okay? So which is easy to verify either this is local minimum or local maximum. And as a result, we can say that so the least squares line for the given data is y equals 0.58 x plus 3.06, okay? So this is the linear regression formula, okay? This is linear regression. At the beginning of the term, first term, we use the GeoGebra to calculate the coefficient of the linear regression formula, but now we calculate this formula by hand, okay? So if you sketch the graph, actually I don't know exactly, but symbolically we can show that in your textbook you can find the exact graph, okay? Actually I forgot the graph, 5, 6. By using some tools you can sketch the exact graph. 6, 7 and 9, 8. These are our points. So among the all lines, the correct line like this one, okay? Let's change. By looking at your textbook, I will sketch the graph because I don't know what is the graph. But using GeoGebra, you can sketch, okay? So the line like this one. Here's our point. Okay. So exactly, I'm not sure it's passed through at that point or not. You can verify. 5. Most probably it's not passed through at that point exactly. But on the using the GeoGebra, you can sketch the exact graph. Okay. So this is the linear regression idea. But in general, how we can write the least square approximation formula? Okay. So let's write the theorem. Theorem 1. Least square approximation. So for a set of n points x1 y1 x2 y2 blah 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 xn yn, okay, the coefficient of the least square line y equals ax plus b. Actually, it's calculated by using this optimization theory, okay, are the solution of the system of normal equations. The normal equations can be obtained from derivatives, okay. So by solving this one from 1 to n xk square times a, this is the coefficient of the from the first equation. So here this is the here, that one, 292, okay. So plus summation from 1 to n xk times b. I will solve some question in the lecture, okay, by using this formula xk yk, okay. So if you look to here, this is the summation of the square of the xk. This is the this is the summation of the xk. This is the not the minus times this one. So 304 is the summation of the xk times yk, okay. And this will be, let's write, summation from 1 to n xk times a. Actually, these are the same, 44, okay, plus n times b. Always we have n times b here because of the minus ones, okay. We have 4 or 5 value in this data, I don't remember. Not 8 value. How about here 8 value? Because we can in the cancelled form, okay, this is the 4 value, okay, and b, and which equals from 1 to n yk, okay. So don't look to these steps, please look to that one. So this is the summation of the square of the xk, this is summation of the xk, this is summation of the xk, this is n for that, this is the summation of the xk yk, this is summation of the yk, okay. So as a result, by solving that normal system, this equation, you can calculate the coefficient a and b, okay. So and these equations are given by the formula, okay, a equals n times, we have already calculated this one, xk yk minus summation xk from 1 to n times summation yk from 1 to n. It seems very complex, but it is easy to calculate that one. N times from 1 to n xk square minus summation from 1 to n xk, okay, square. And the b value is from 1 to n yk minus a times from 1 to n xk over n, okay. So by using these formulas, you can calculate the your coefficients easily, okay. So this method is known as a least square method. So for linear regression analysis, you can use that formula. In the problem solving hour, I will solve some questions related with this formula.